Okay, so same question again. If I make this a commission employee reference, but the class is the same, base plus commission employee, would this program compile and run? Anybody? So this is a C++ question actually, not a Java question.
Yes.
What?
Yes.
Yes, why?
Because it's an reference actually, and I think it can be done.
Because there is a relationship it runs? Is that what you mean?
Yes, and
Because, I mean, the commission employee, all the base plus commission employees are commission employees. That's why I can make this assignment. This is a simple upcasting, and upcasting always works. It works, but the thing is this. Get first name, get last name, get social security, get cross sales, they are all okay, but employee, this base commission employee doesn't have a base salary. This one will not work, right? This one will give me an error message. It will say that employee is of type commission employee. Inside the commission employee, I don't have to get base salary. So until this line, everything works fine. But for this line, it's not going to compile. It will tell me that there is something wrong with this code, because get base salary doesn't belong to commission employee class. I think we did this when we give the examples of the slicing. Remember the slicing problem with C++? We assigned an object of a dog to a pet, and we said that this doesn't work, and etc. In this case, there is no slicing happening, but of course, through the pointers, I can say that I can access all the elements of the superclass. Okay. So is this clear? This is important. Again, this is not a Java question. This is an inheritance question. The same problems or the same things, same rules valid for both C++ and Java or C#, whatever object-oriented programming language you are using. Okay. Is a relation is there? Is a relationship is there? I can make this assignment, but if you like to access the base salary of this commission employee, this reference is not good. This employee is of type commission employee. It's not going to work. That means that there is a slicing problem. No, there is no slicing problem in Java. Slicing problem cannot happen. Why the slicing problem is not possible in Java? Can anybody tell me? Slicing problem is not possible in Java. Why is it not possible?
everything is referenced.
Because everything is in reference, there is no object assignment in Java, right? I cannot assign one object to another object because everything is references. All I'm doing is just reference assignments. With the reference assignment, nothing is lost. Okay? If I have a commission employee here and a base plus commission employee here, okay, my reference can both point to this one or that one, okay, doesn't matter. Okay, this could be an object reference. Okay, an object reference can point to both this one and that one. Okay, so no problems. So there is no slicing problem, but through this reference, I cannot access any of the methods of the commission employee or base plus commission employee, other than the methods of the object. Okay, good. So let me move on. So this is a table about what happens, what kind of about the effects of the access modifiers. In a class, if I say something is public I know what happens. If something is public, I can access that thing inside the class, inside the package, inside the subclasses, and inside the whole other world, okay? So because it's a public, so it is available everywhere. If I make something protected, that thing is available inside that class, it is available inside that package, it is available in all the subclasses, extended classes, derived classes, but for the outside world it behaves like private, right? If I don't put any modifiers at the beginning of a method or a data field, okay, so this could happen, it is like this. What did I say before? You have to put public, private, protected at the beginning of the things, members of a class. Well, it is possible to say this, okay? When you say this, it is called package level visibility. It is not public, private, protected. It is package level visibility. If you do that for the package level visibility, it is available for usage employment inside the class, inside the package, but it behaves like private for the subclasses and the outside world. Okay? So as long as you are in the same package, this add num will work fine. Question for you in this case: would this code compile and run after I remove that public method in there? Would this code compile and run? Add num, I only used it here, line 38. It should compile and run. Why not? Why? Because main is part of this class, right? Add num class, and inside the main I am calling the add num method. Add num method is part of this class. So what is the rule? The rule is for the modifiers, okay, no modifiers. They are available within the class. They are available within the same package. They are not available in the subclasses of the world. So I am in the same class. So this should work fine. So let me put it back. Now this is available for everywhere else. And we know about the private. Private is only available within that class only. It is not available within the package or subclasses or the world. Okay. So one more level of access privilege, okay? So this no modifier is between protected and private, maybe, yeah. Public is the most general one, private is the most restricted one, then comes the protected, then the no modifier, then the private. No modifier is kind of like no name namespace, right? It's something like that, but it's not exactly the same, but it is similar. Okay? So it is package level access. So package level access is maybe kind of compilation unit level access, but there is no term such as compilation units in Java. Okay, it is available only in C++. That's why we defined the unnamed namespaces for C++ using the concept of compilation units. In this case, we don't have the compilation units. We have the packages, and for the packages, we have no modifier access level. Okay, it always helps to compare languages like this. It will make you understand both languages better. Okay, when you learn English, that will make you understand Turkish better. Okay, when you learn some other language, it will make you understand. For example, when you learn English, okay, when you learn about the articles, the and a, we don't have articles in Turkish as explicit as in English, right? So you start understanding the difference between adam and adamı, right? So it's like you better realize the kind of things in your own language, okay? As an English speaker, native speaker, when they learn about Turkish, they start understanding stuff like accusative and dative better because they don't have those kind of stuff in their language. The same thing, okay? So when you learn about Java, when you try to express the concepts in the other language, you understand them better. Of course, when you are writing code in Java, you don't think about writing them in C, right? That would confuse you. That would be bad. Like when you talk in English, you don't think in Turkish. That would be a bad thing. But it always helps to compare the languages when you start learning them or when you're trying to make sense out of those things. Good? Yes?
Is there a no modifier access level in C++?
No, we don't. I didn't teach you anything like that. Right? Yeah. I taught you everything that I know about C++. So if I didn't tell you, then I don't know about that. No, there are only public, protected, and private. That's it. Okay. So, but remember, we have other stuff. I mean, we have global functions, global variables in C++. Okay, those are all publicly available everywhere. If you combine that idea with the idea of unnamed namespaces, then it looks like no modifier package level access. It looks like it. Okay. So what is the modifier for a global function? Nothing, right? So in a way that it is similar to this one, but you might say that global functions are available for everywhere. That's true, but unless you put them in an unnamed namespace. In that case, that global function is only accessible in that unnamed namespace or compilation unit. Okay. Good. Any other questions? Let me move on then. Okay, our object class again. As I said before, you cannot prevent this. If you write a new class in Java, whether you, we forget about this. Nobody asked me about this. So you have been all sleeping. Base plus commission employee extends commission employee. I didn't put my finger on this keyword. Extends our new keyword. Well, I talked about extension as a term, but not as a keyword. Okay. This is how you do the inheritance in Java. So did you guys notice this? Did anybody notice it? Nobody asked me about how you do the inheritance in Java. So you did not notice this line number 5?
I think you said it.
I said it. I said that the term is extend, but I didn't put my finger on this keyword and say this extends. Okay, extends is a C Java keyword. It is not available in C++. For this one, if I am writing this one, I would have said column and public, right? This is for C++ instead of extends. In Java, we use the term extends. Okay? So, if I come back to this one, whatever you do, okay, if you don't like it or you like it, your classes will be extended from this class object. Okay? If I am writing a class named my class, it automatically extends object. You don't have to write it, but you could write it if you like. Okay? You don't have to write it, but if you can write it if you like. But nobody writes it. Nobody writes it because everybody knows about it. And what does that mean? If all the classes automatically extends object, they automatically inherit all of these methods. So this is a much better way of telling the newcomers that, okay, these methods are always available through inheritance. And in C++, what do we say? Whatever you do, if you have a class like this, class A, okay, this one has a default constructor, default copy constructor, destructor, copy assignment, move constructor, etc. We iterate over these functions one by one, and we tell them that you have to memorize this. Well, in this case, you don't have to memorize anything because all you need to know that all the classes extend from this class object. So So to know what kind of things you are inheriting, then all you need to do is you go to this object class definition and see what is available. Okay. So clone is like copy constructor, but of course it's not a copy constructor. Equals is for comparing objects. Okay. Let's look at this one. Well, I told you about this one, but I didn't make it explicit. Maybe I should look at this one. Okay. So let's say I have two integers, a and b. Okay. If I say a is equals b, this one will return false, and this if statement will not be executed, right? Because a is not equal to b. I know that one, right? How about this? I have money M1, new money $10.20, and I have another money object M2, new money again, $10.20. If M1 is equal to M2, do you think this if will be taken, this will return true or false? Well, the objects are equal, it looks like. Objects are equal, it looks like, right? Because they have the same integer amount and dollar amount. But we didn't overload any is equal to operator, right? Well, there is no operator overloading in Java anyways. So what kind of thing? Well, I mean, here is the case, okay? I am asking if this reference is equal to this reference. I am not asking if this object is equal to that object, right? So that's what I'm doing, okay? So these are the reference equality. These references are not equal, right? They are pointing to two different objects whose internal data members are equal. But, I mean, these references are not equal. So this will return false. Okay, this is true. So how would I compare these objects, these two objects? This is what I do. I will say if M1 dot equals M2. Okay, that's what you should do. But this equals is implemented in the superclass object as comparison of the references. Okay, it doesn't compare the internals of the object itself. It just checks the addresses. So this one and this one are the same thing if I don't override it, okay? If you override this equals method so that it works fine, it works as in comparing the integer parts to the dollar parts and the cents parts, then it's going to do the intended thing, that is comparing those two money objects with the dollars and cents part. Otherwise, compiler cannot know how to compare these kind of money objects. I mean, should I compare the cents part and the dollar part? Maybe ignore the cents part, etc. It doesn't know. Okay. So the default meaning of this equals, as implemented in the superclass object, is the same as reference comparison. It compares the references. So that's what the default meaning of equals. Okay, finalize, we already looked at it. Get class returns the class related information via my class name and etc. Hash code is something that is related to equals actually. Okay, know this much because next semester you are going to talk about the hashing and etc. If two things are equal, their hash codes are the same. Hash code returns an integer, okay? So given an object, there is always a hash code. It returns a number. If two things are equal, their hash codes are the same too. Okay? If two things are equal, their hash codes are the same too. That's why for default, the hash code returns the memory address of the object, okay? If I return the memory address of the object, two things are only equal if they are the same object in the main memory, right? So by default. So the rule says that if you are overriding equals, you need to override hash code too. Because if two things are equal, if their dollar parse and the cent parse are the same, then your hash code should return the same thing too. Okay, and there are nice ways of doing those kind of stuff, and we already know about the toString. Okay, so in Java, whatever class you have, you can print that class's objects by default because toString is available. Okay, so let's look at these methods one by one. Maybe clone is a protected method. What does that mean? You cannot call the clone method for a new class unless you override it and make it public because it is protected. So by default, your objects are not clonable by anybody else. Okay? By default, your objects are not clonable by anybody else. And if you clone it, you call the superclasses clone method, which does the shallow copy, and you add your stuff on it. I'm going to show you in an example in a few minutes. So clone is this, equals is this. Okay, it should return true or false. Okay, that's the thing. And the default meaning of equals is the same as this operator. Okay. For the integers, this works fine. For the numbers, for the fundamental types, it works fine. For the reference types, it just compares the reference. It just compares the addresses. That's the equals. What else? Finalize. We talked about it. Get class returns a object of a class named class. Very confusing, very stupid name. Okay. There is a class named class. Standard class that starts with a capital C, of course. Okay, inside this Java lang, this get class returns an object of that class. Okay, whose name is class, and you can get information about that thing using the get name and etc. Maybe I'm going to look at it in more details for a few minutes. Maybe I won't. I don't know, so I will skip it. Hash code, I talk about it, and notify all wait are about multi-threading, as I said before. It's for synchronization, it's for inter-process communication, inter-thread communication, etc. We talk about the thread. By the way, remember this one? This one printed something, okay? Not that meaningful. I said that the name of the class and some number. This is the hash code of that object. So toString by default returns the class name and the hash code of that object. So it is, I am not saying that it is not that meaningful, but it is. Can I get the same thing when I run it? Yeah, it is exactly the same thing. Because Java Virtual Machine is every time when you start it, it starts the same Java Virtual Machine in the virtual world. So you would expect, I mean, it's not like C. In C, when you say run this, and you may get a different memory position for the same variable, because it depends lots of stuff going on with the operating system. But for the Java Virtual Machine, it is isolated from the operating system. It's a new virtual world. So this is the address of that object in my memory. If I can, let me make an integer somewhere. Can I? Okay, let's do this. Object 2 and object. I made another object, so I am hoping that it's going to change its position in the memory because I modified the memory a little bit. Well, it is exactly the same. I don't know. So I don't know what the Java virtual. Maybe it optimized it because I never used that object too. Maybe it did not produce any code about it. I don't know what kind of things it is doing. So in Java, really, you don't talk about the addresses. In Java, you just write your code and Don't worry about those kind of details. It's not like C, C++. Okay, so the toString, it just prints the name of the class and the hash code of it, which is the memory location by default. Okay, any questions so far? Polymorphism. Of course, after the inheritance, polymorphism will come. Polymorphism, the meaning is exactly the same, making the decisions of which methods to call during the runtime depending on the object type. Okay, object type through the reference. Okay, we have the references like the pointers. So what was the rule in C++? If you are calling a function through a reference of a base class or through a pointer of a base class, and if the object is if the function is a virtual function, then polymorphism will happen, right? That was the rule. The same rule happens here. In Java, there is no other way of calling functions or methods. You have to use a reference, right? Without the references, you don't call the methods. Okay? So if the reference is a superclass reference, and if you call the method, and all the methods, as I told you, are virtual by default, okay? They are virtual by default. So most of the time, these are the polymorphic calls. Most of the time, these are the polymorphic calls, okay? So when a program invokes a method through a superclass variable, superclass reference, the correct subclass version of the method is called. Okay, so that's the thing. The same method, same name, same signature can cause different actions to occur depending on the type of the object, object. toString is something like that. Okay, let's look at this one. In Java, we can have a method, let's say a method, void PR print, okay, an object array OA. Okay? What does this look like? Okay, when you look at this one, is it what kind of function could you write in C that would look like this? Well, I mean, this can take any kind of array, right? I mean, this is an object array. So what would be the corresponding thing in C or C++? If I have a function that takes an array of what? What? Pointers, what kind of pointers?
Auto.
No, but there is no, I mean, you cannot. Auto deduces by looking at the right side of an assignment, no. Pointers of what?
Void pointers.
Yeah, exactly. Void pointer array would be exactly the same thing. That's why I would like to say void pointers are like object references in Java. With an object reference, you can point to anything you like. With a void pointer, you can point to anything you like, right? In void pointers, what kind of things can you do? Can you increment a void pointer? No. Can you add values to it? No. Can you make a function call with a void pointer? No, you can't. In Java, with the object reference, can you make any method calls? Of course, I can call toString, clone, hash code, equals, and etc., right? So this one is much more functional than void pointers, but the ideas are the same. This is as generic as you can get in Java, and this is as generic as you can get in C and C++. Okay, but this one does not leave the world of object-oriented programming. This one is, of course, is like the wide west. You can do anything you like, including the good things. Okay, so let's go back and let's try to write this code. What am I going to do? This is what I am going to do. I will say for object O object array O, okay, system out print line O dot to string. Okay, it's like magic, it works. So what does it do? It takes an array of objects, and every time at each iteration of this enhanced for statement, toString method of that object is called, okay, and it will be printed, okay. This will work for any kind of object. This will work for any kind of object. No matter what the objects are, okay. So it works. Better yet, let's get rid of this one. This will work. Why? Because Java knows how to convert any object to a string, right? So this is a very generic function. This is a very generic method, okay? You cannot get any more generic than that. And this method will work for any kind of array, okay? And by the way, in this array, let's call this print method. In my some other function, let's say I have a money object like this one, dot dot dot. I have a string object s1 dot dot dot. Okay. Now I have this object array O. Okay, I am going to call it array is new, okay, object 2, okay, array 0 is M1, array 1 is S1, and I am calling that method print array. Okay, so I place the things that I want. M1 and S1 is a relationship that can happen there, and each one is going to work. So each of these toString methods, let me put it back to toString methods, dot toString, okay. Each of these toString methods, okay, will be polymorphically decided. I have written this code in 1995 when Java was first invented, and this code will work for any classes that was written for the 30 years after 1995. Okay. So this is as generic as you can get. So what was the main idea of the polymorphism? Write generic code. Okay, write generic code. Whoever has a new class, it will keep running. Like your homework, you have especially the bonus part of your homework number, what for? Bonus part of, I guess, number 5 or number 4? 5, yeah. You have written an intelligent algorithm, okay, using those polymorphic function calls. Your intelligent algorithm, like magic, works for any kind of board game, right? As long as it follows the rules. It works for 8 puzzle game or the other Scrabble game, or I don't remember the names of the games. As long as the games fit the format, 2-dimensional boards and single player games, that intelligent algorithm works for them. Okay, so you have written, I am not saying you because only 5 people submitted, I guess. 5 people have written intelligent code in a very generic way, and it works for new classes. Okay, this code will work for new classes because this function call is a polymorphic function call. It doesn't know what toString method it would call until the runtime, until the last time. That's why it is late binding. So the idea is there. So let's look at this polymorphism idea. Okay. So polymorphism test again. Commission employee. I have this commission employee. Base plus commission employee. Base plus commission employee. So I am pointing to the correct type of objects using the correct type of references. Okay, I call their toString methods, but then I do this. Using the is-a relationship, I assign this base plus commission employee, which is the extended class object, to the superclass object, and I call the toString method of the commission employee, which is a superclass, and as the polymorphic behavior, suggests, I am going to get the correct method to be called. Okay, so this one will call the base plus commission employees toString method. Okay. So the polymorphism is there. It is much easier, and you don't have to say my functions are, my methods are virtual, because all the methods that you have defined, if you don't say the otherwise, they are all virtual. They are all late binding functions in Java. So every time you make a function call like this, during the runtime, Java makes a decision which function to which method to call. Okay, so that's another hit for you for the CPU time, but as I said before, we already know that. Okay, we already agreed about that CPU time hit. Okay, it looks like I am out of time. I'm going to stop on time for today because you have a quiz, I guess. So that will be it for today. If there are any questions, I can answer, but you are free to go now. Any questions? Soru yok. İyi, tamam. Bence siz beni dinliyorsunuz, anlıyorsunuz da bana cevap vermiyorsunuz değil mi? Öyle değil mi? Gerçekten inşallah öyledir ya.